So don't stop believing. T is for T-Test, independent or dependent samples. It's time to review the T-Test for dependent samples and T-Test for independent samples. Well, hi, class. This is Chris Burgos, and I'm completing my graduate project regarding t-tests for independent samples and t-tests for dependent samples. Today, I'd like to talk through some examples of how we would use these different tests. I want to talk about the similarities between the two, the differences between the two, and then have an opportunity to allow you to work on the examples that I provided as a means to review for our final exam and to be able to give you some ideas that may flavor some research ideas that you may have within your particular interest or your particular field. And so I hope this is a helpful presentation for you. And if you have any questions about anything that we talk about today, please feel free to email me. I'll have my email address at the conclusion of the presentation. So let's talk about the similarities between the t-test for independent samples and t-test for dependent samples. Obviously, we are examining or we are testing the difference between groups of one or more variables. In addition to that, we are working with or we are dealing with two groups, so an A group and a B group. There are other examples that either our text uses or other text use, like a male group and a female group, the graduate class versus the undergraduate class. So we are looking at two groups within both of the t-tests. But we wouldn't use a t-test if we are testing the difference between maybe a sample and the population. In that case, we would be using a one sample z-test. So let's talk about the differences between the two. We'll start with the t-test for dependent samples. Obviously, like I just mentioned, the t-test for dependent samples does meet the criteria um, in that we are testing the difference between groups of one or more variables. In addition, we are working with two groups. The specific difference is within the t-test for dependent samples, we are examining or the examination the participants are going through, it's occurring more than one time. So, for example, there's a pre-test and then there may be a post-test. That's different than the t-test for independent samples in that the examination the participants are going through is occurring only one time. So let's talk through an example, a real world example of a t-test for dependent samples and how that would be utilized in that the participants are being tested more than one time. So here is our example. A administrator of a skilled nursing facility heard about this exceptional program in which listening to music can help reduce a resident's self-reported measure of pain. And so, in wanting to test that idea, the nursing home administrator implemented the program and did a pre-test so that the resident would report their pain prior to listening to music, and then they would report their pain on a scale based on after listening to the music. And so the group of participants are being measured more than one time, therefore warranting a t-test. And there's two groups, so we are therefore warranting a t-test for dependent samples. So now let's look at this chart. We have resident 1 and resident 2, and there is a pre-test for pain before the music listening interventions and a post-test that measures the resident's pain at the conclusion of the music interventions. So we have resident 1 and resident 2. Their pre-test scores were 7 and 5 respectively, and their post-test pain scores were 8 and 6 respectively, both leaving a difference of 1. Therefore, the sum of differences would be 2, 1 plus 1. Then we are looking at the sum of differences squared, which would be 1 and 1 meaning that there would be a total of 2. So it is time to look at what the null hypothesis would be. To determine that, our null hypothesis would show that there is no statistical significant difference between the post-test and the pre-test scores as we can. So we have our opportunity to determine the test statistic. And so we see a couple of symbols here, and we'll talk through those as we mentioned a few already. But we look at the section on the numerator, which is the sum of the differences between the groups of scores, which we see on the previous table. We see on the bottom portion, we have the sum of differences squared between groups of scores, and the n is standing for the number of pairs of observations. So once we have all that information, we plug that in order to determine what our test statistic is. And I'd like you to go ahead and do that now. So once we plug everything in, we would determine what our test statistic is. We will then need to find the critical value by taking the degrees of freedom, which in this case, the degrees of freedom is n minus 1. We will determine the level of risk, so the arbitrary determination would be 0.05. And then we would find our obtained value that we used to find within the test statistic in the previous equation. We would look to find that on the table in Appendix B2 in the textbook. If we see that the obtained value is more extreme than the critical value, then you need to reject the null hypothesis. So, if the obtained value is not more extreme than the critical value, then you would fail to reject the null hypothesis. Therefore, the music had no effect in this case. Therefore, the broken guitar. So now, how about t-tests for independent samples? So I want to use an example about that. As a nursing home administrator of a community that has 2 halls of skilled nursing beds, the same amount, I want to measure the mean fall risk of Hall 1 compared to Hall 2. So fall scores are determined for each resident from 1 to 10, 1 being a very low fall risk to 10 being a very high fall risk. And I'm wanting to know if one hall has any significant difference between the two in terms of the fall risk of residents. So here you will see the mean fall scores that we measured in our facility, and you look at the fall scores between Hall 1 and you look at the fall scores between Hall 2, and it has the different mean scores. Each hall has a total of 14 beds, and each of these mean scores are for each resident. And so we want to determine the null hypothesis. And our null hypothesis would be that there is no significant difference between the average fall risk scores in Hall 1 versus the fall risk scores in Hall 2 of the skilled nursing facility. We also want to take this opportunity and determine the research hypothesis, which there is a significant difference between the average fall risk scores in Hall 1 versus the fall risk scores in Hall 2 of the skilled nursing facility. I want to know if there's a difference between the two to begin looking a little bit deeper at patterns in the future. So now it is time to calculate the test statistic. And I know each of you have seen this formula in the past within this course, and it's really simple. We're really just using some simple arithmetic to plug in the numbers. So in the numerator, we're looking at the mean for group 1. We're looking at the mean for group 2. On the bottom portion, we're looking at the number of participants in group 1. We're looking at the number of participants in group 2. We're also looking at the variance for group 1. That's the S21, and then S22, the variance for group 2. So you want to just take all of these numbers and plug them in order to calculate the test statistic, which I will give you the opportunity to pause and to do that on your own to be able to So once we find the obtained value, we need to find the critical value. So first we would need to find the degrees of freedom. And in order to find the degrees of freedom for a t-test for independent samples, you want to add the size of the two samples together, so 14 residents per hall, giving us 28. And then you want to subtract that by 2 for the two groups, giving us 26. Using zero point 0.05 as the level of risk, we again want to go to Appendix B2 in our textbook to look for the two-tailed test, find the degrees of freedom, and the obtained value that we found in order to determine what the critical value is. And once we find what that critical value is, if our obtained value is more extreme than the critical value, then you need to reject the null hypothesis. So there is a statistically significant difference between the fall risk scores between the two halls. But if the obtained value is not more extreme than the critical value, then you want to fail to reject the null hypothesis. In that, there is not a statistically significant difference between Hall 1's fall risk scores for residents and Hall 2's fall risk scores for residents, which would therefore give the nursing home administrator and the director of nursing some pretty valuable information in terms of how to move forward and to further investigate. So now it's your turn. The learning objectives within this project and this module were to come up with some real world examples that are meaningful to you in terms of the profession that you're in, the area of research that you are interested in, whether that may be healthcare like it is for me personally, but it may be different for you. You may be interested in education or some other area that you can utilize this information to be able to provide some specific and some objective insight. So that's my goal, is to bring the theoretical concepts that we have learned this semester through our text, through the lectures, through the PowerPoints, and to provide some real world examples. So what I would like you to do is I would like you to use the examples that I provided to be able to come up with the test statistic so that you can ensure that you are doing the work correctly. But in addition to that, I want you to create some examples for yourself. And you don't have to physically go out and do the experiment. You can create some quote unquote fake data, but I want you to be able to utilize it to be able to find information that is relevant to the work that you are doing. I left my email on here, so if you have any questions for me, feel free to email me. And I hope this was a helpful presentation for you. It was very helpful for me to be able to solidify some of the content that I've been learning throughout the semester and being able to apply that in a very practical nature. Thank you very much for listening, and I hope you have a great day and a great remainder of the semester.